This is your tutor, Voltaire Sibal. This video contains topics on basic mathematics.
A set of real numbers. The set of real numbers is the set of all numbers. So this big set of all numbers have several subsets under it. So we'll discuss this one by one. Let's start with the smallest set, and that is the set of natural numbers. So the set of natural numbers has the symbol capital N. So the set of natural numbers is also called the set of counting numbers. So this includes one, two, three, 4, 5, and so on. So these are the numbers that you use to count. So is 0 included? No, because you don't count starting with 0. You count starting with 1. And then next, after the set of natural numbers, we have the set of whole numbers. So the symbol for the set of whole numbers is capital W. So the set of whole numbers is just the set of natural numbers plus the number 0. So the set of whole numbers is equal to 0, 1, 2, 3, 4, 5, and so on. So basically, it's just the set of natural numbers and you add 0. Then the next bigger set is the set of integers. So the symbol for the set of integers is capital Z. So basically, the set of integers is just your set of whole numbers, and you just add the negative counterparts. So that means the set of integers is equal to the set of all negative numbers starting from infinity, then down to negative 5, negative 4, negative 3, negative 2, negative 1, and then after negative 1 is your number 0, and then all the positive whole numbers 1, 2, 3, 4, and so on. So you could notice that this from here up to here, this is just your set of whole numbers. And then from here up to infinity is your set of counting numbers or the set of natural numbers. And then here up to negative infinity are just the negative counterparts of your natural numbers or counting numbers. So after integers, we go to the bigger set, and that is the set of rational numbers. And the set of rational numbers is symbolized by the letter Q. So why Q? I think this is probably because Q means quotient. Quotient refers to fractions. Or you could also notice that the root word here is ratio. So ratio means fractions also. So you can tell that rational numbers have something to do with fractions. So basically, all numbers that can be expressed as fractions could be classified as a rational number. So the set of rational numbers would also include decimals that are terminating decimals, like the decimal 0.123. So terminating because it stops here at 3. There are no more numbers after it. And then the set of rational numbers also includes the non-terminating and repeating decimals. So we go back here. So why is the number 0, 1, 2, 3, or why are terminating decimals considered rational numbers? Because 0.123 is actually convertible into fraction. So 0.123 is just 123 over 1000. Now why are non-terminating and repeating decimals also considered rational numbers? Let's say, for example, an example of a non-terminating and repeating decimal is the number 0.333 dot 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 or 0.3 bar. So is this convertible to a fraction? Yes, because 0.3 bar is just 1/3. So all decimals that are repeating, meaning they have a pattern of repeating numbers, and they could be non-terminating, meaning the numbers could go on forever, could still be converted into fractions. So they qualify to belong to the set of rational numbers. So aside from these two, the terminating and non-terminating decimals, number the other members of the rational number sets are, of course, your fractions, and your integers. So again, integers are the negative counterpart of your counting numbers, the number 0, and of course your counting numbers. So to summarize, before we summarize, there is still another set, and that is your set of irrational numbers. So the symbol for irrational numbers is just q prime. So basically, the set of irrational numbers are all those other numbers that are not rational numbers. So meaning all those other numbers that could not be converted into fractions. So you might be wondering, are there any such number? Is there any such number? So an example is the square root of 2. So the square root of 2 is a value that looks something like this. It's 1.414213 and so on. So the number contains decimals that are not terminating and have no pattern. So since there is no pattern, there is no way to convert it into a fraction. So another example of an irrational number is of the square root of 3, and another one is the number pi. So pi is also a number that looks like this, 3.14 dot dot dot. So again, just like the square root of 2, the decimal numbers are have no pattern and is continuous.
Okay, so another cool way of explaining the concept of real numbers is by representing them into sets. So in this case, we'll represent the sets as circles. So again, the set of real numbers is the set of all numbers. So under the set of real numbers, we have uh, two main subsets, which are the rational and the irrational numbers. So we'll try to draw a circle to represent these two subsets. So we try to label it. So this is your set of rational, and then the second set of irrational. So under the large circle or the large set of rational numbers, we have a smaller subset, and we could represent it as a smaller circle. So we call this set the set of integers. So again, integers are a set of numbers that are positive and negative. So inside the integers, we have a smaller circle, and this is a set that we call the set of whole numbers. So the set of whole numbers are comprised of numbers that are whole, meaning they're not fractions. And then inside the set of whole numbers, we have the last unit or the last subset. So it's a smaller circle, which is called the set of counting numbers. So let's say, for example, we have some examples or some numbers here. So let's say we have negative 1/5. Let's say we have negative 2, the number 5, 0, 0.3 bar, pi, and square root of 3. So let's try to classify these different numbers, and let's see where we could place it in this illustration of sets of real numbers. So everything, all of these are inside the big set of real numbers. So let's start with negative 1/5. So we can see that negative 1/5 is a fraction and it is negative. So where should we put this? So negative 1/5 definitely belongs to the set of rational numbers. It is not irrational. So it is inside the set of rational numbers. But we could not place it inside the set of integers because it is not whole. It's a fraction. So we put it outside integers but inside rational. So negative 1/5 will be placed here. And then next, negative 2. Negative 2 is whole and it is negative. So it is whole and negative, so we place it here. Negative 2 goes there. And then 0. So 0 is a whole number. It is not. It is an integer because integers are comprised of positive and negative numbers, including 0. So 0 is here. And then 0.3 bar. So at first glance, we might think that 0.3 bar belongs to the set of irrational number because it contains an infinite number of decimal values, infinite decimals. So it may seem irrational, but actually 0.3 bar can be converted into a simple fraction. So this is just equivalent to 1/3. So 1/3 is a fraction, so it should belong to the set of rational numbers but outside integers. So 0.3 should be here. 0.3 bar should be here. And then the number pi. So as we know, as we've learned earlier, that pi is irrational because it cannot be expressed as a fraction. Now some might think that pi is equivalent to 22/7. So this is not accurate, or this is not entirely correct. So 22/7 is almost equivalent to pi, but not really. So 22/7 is just an approximation of pi. So 22/7 is rational. So we could put 22/7 here, but pi is irrational because they're not equivalent. 22/7 is just an approximation. It is close to pi, but it's not equal. So pi should be under the irrational number set. And then finally, square root of 3. Square root of 3 cannot be in any way represented into a fraction. So if you use your calculator and you try to find the value of square root of 3, you would not get a complete answer because it is a decimal that is non-repeating and random and never ending. So irrational. So it could not be expressed as a fraction. So there you go.